Over here we have a circuit, a resistance and a coil inductance, which is connected in serial, a switch to connect and disconnect the system, and a DC voltage power supply. What will happen when we close the switch? Will there be a current through the system, or what will happen? We know from before that the coil induction doesn't want to change in the magnetic field. So when we have a supply voltage here, it will create a current and a magnetic field, and the inductor or coil will generate a voltage the other way, so that the current will be zero and thereby a constant field. So we'll think that the current will increase, but it just takes some time because we have the generated voltage which want to bring the current to zero, or that the current doesn't change. We can see down here that the current, that's the blue line, and the generated voltage in the coil, self-induction, is this line. And probably you can see from before, it looks like the lines for the capacitor when we charge and discharge the capacitor. And we can see up here the formula is also hereby the same. So when we have to calculate the intermediate current, we must take the maximum of the current, multiply by 1 minus an Euler's number, power to minus time, multiplied by the resistance, the value for the resistance, divided by the inductance, the value for the inductor or coil. The maximum current when we switch on the system, that must be when the induction voltage is zero, so it is just the supply voltage divided by the resistance. We can put this value in the formula up here and then calculate the current at every time. We also say here that after 5 time constants, we said that the current is nearby maximum. I think it was 99.3%, so we just said it is at maximum. And also at 1 time constant, we have it had reached 63% of maximum. The formula is nearby the same, just calculating the current, but up here we know that the power here is minus time divided by time constant tau. So time constant is here, the inductance divided by the resistance. And normally the inductance is a very low value and the resistance can be a high value. So normally this will happen very fast. We also have a formula if we want to calculate the voltage that the coil inducts. So we can also calculate the voltage for this curve at any time. When we're going to disconnect the system, we'll try to find out what will happen, because we have a danger of high voltage. Because when we connect the system and after a short time, the current will be maximum. When we then disconnect, the coil said that, okay, we have a current, we have a magnetic field. I don't want to change that magnetic field or current. And the current go clockwise. So the current go down over here in a coil, and if the coil should generate a voltage, so the current still go downwards, it must generate a voltage here, which is positive. So when we disconnect, the coil generates a voltage which has the opposite polarity of the supply system, or plus here, minus here. And it, for example, can start generating the supply voltage, but it doesn't help bring a current in the system because the switch is disconnected. So the coil says, okay, I must generate an even higher voltage to bring a current, so that will keep the current, same current as before, and then the magnetic field. And the voltage will increase, and it can be many times the supply voltage. Sometimes the equipment that we have connected is not designed for that high voltage. So we have to take care and protect the system, all the components, and take care that this voltage will not be that high. We can help the system by connecting a semiconductor here, so that the current will go this way. A semiconductor has an anode and a cathode, and it will lead the current only one way. That's why it's called a semiconductor. So if we put on a semiconductor here, diode, it can bring the current this way, but not the other way. So when we have the normal supply situation, the current will not go down here, it will just go in a coil. But when we disconnect, we can bring the current this way, and the high voltage will not be generated. So take care when you disconnect a coil.